Okay, I just got a question today about, kind of goes into actually some other things that I've actually made some other videos about. And that's to do with the scaling of Moxie. So this 0 to 100% scale that the Moxie provides. The question is, well, what does 0 mean? What does 100% mean? 0 really 0, which something I've answered before in a different question. And how does that scale differ from other NIRS devices that may also show kind of the 0 to 100% scale? I think it's a pretty important question, and I think there's always some kind of misunderstanding on perhaps what NIRS is really measuring. So the problem with NIRS, as already stated, is that you can't really quantify the data that you're getting. So you're getting some kind of arbitrary units, some relative values of, you're getting a light signal of absorbency. But that's just so physiological. You're getting a relative value of oxyhemoglobin and deoxyhemoglobin. Those are being differentiated. And what you don't get is a value of a quantified value of total hemoglobin or oxy or deoxyhemoglobin, or some kind of value of your actual muscle VO2 and how much oxygen is being consumed. You don't get any of that. You just get these relative measures. Now, to kind of create some robustness, you can create a percent, or you can make a percent, which is by definition then a relative value, and that's going to be easier to compare. And it's going to put it on a comparable scale from 0 to 100%. Now, that turns into the question, well, if you put it on a scale from 0 to 100%, what does 0% mean and what does 100% mean? So 100% is essentially your maximally oxygenated, and your 0% would be your maximally deoxygenated. So your maximally oxygenated point and your maximally deoxygenated point. And looking at it from that perspective, there's actually some groups out there. Macaulay uses this a lot. It's called the physiological calibration. And essentially you try to define this 0 to 100% scale individually. So if you do an occlusion and you completely stop any kind of blood flow to a limb, you get to see how low your muscle oxygenation is actually going to go down to. So how low is that signal going to get down to? And the low point of that signal that it gets down to, where it plateaus out at the bottom, because it's going to go linearly down, and then it's going to plateau at the bottom. And that plateau is your maximally deoxygenated state. That is your 0%. And then when you open up the pressure cuff, you're going to hyperemia. So it's going to overshoot really high, and you're going to get your peak point, your highest value you're going to find. That's your maximally oxygenated state. So that would be, let's say, your 100%. So now that you've defined, well, what does 0% mean and what does 100% mean? And you can find that out through a physiological calibration. So those values are attainable. You can now discuss what that means for the Moxie. So if you get a 0% on the Moxie, it means you have now maximally deoxygenated. And if you have 100%, you have maximally oxygenated. So you have this entire spectrum. If you're using a different NIRS device, that's going to have its own scaling, and it's going to have a 0 to 100% scaling, and it plateaus out at 30%. Well, 30% would then essentially be your maximally deoxygenated point. And if it only hyperemia is up to 70%, well, that's your maximally oxygenated point, and that is actually your scale, 30 to 70. And so then you start to question, well, why would 30% be maximally deoxygenated? Shouldn't that be 0%? Logically, 0% makes more sense. So that's really what the Moxie has tried to do, is actually make a functional scaling, understanding those two terms, maximally oxygenated and maximally deoxygenated states of 0 and 100%, and try to come to that as close as possible. And that's not as easy to do as you think it is. There's a lot of technical problems with that. And especially because you're trying to avoid negative numbers, for example. So a lot of devices are much more conservative in their scaling. And that's why you get these much tighter ranges. So like I said, for example, 30 to 70%. So that's something to consider, and that hopefully helps a little bit with the explanation of the scaling. Like, can there really be 0%? Yeah, 0% is just maximum deoxygenated state. And if your device does a good job at finding those 2 points, 0, 100%, then essentially every person that you did a physiological calibration with should show a 0% and let's say a close to 100%, because, or a close to 0% and a close to 100%, because then the scale will be working accurately because it's getting close to those 2 definitional points. I hope that wasn't just gibberish. Hope that makes sense. If it wasn't clear or something was misunderstood, please just send me an email and ask me again, and I will try to do better next time. Thank you very much. Bye-bye.